Welcome back to my channel. In this video, we are going to discuss about the double integration method. Right? So this double integration method is used to obtain the deflection of a beam basically by integrating the differential equation of the elastic curve of the beam two times. So this is one of the method which is used to find out the deflection of the beam. And after integrating the differential equation twice, we are going to get some constants of integration. So normally we will apply the boundary conditions to find out those constants of integration. And the first integration usually will give the slope of the beam, and the second integration of the differential equation will give the deflection equation of the beam. So this is the general idea about the double integration method. So now I am going to explain how to solve a problem using double integration method step by step. So the first step is to determine the bending moment at an intermediate point X on the beam. Step number 2. So after finding the bending moment at any point on the beam, I'm going to substitute that particular bending moment value into the governing differential equation, and our governing differential equation is nothing but m is equal to ei into d square y by dx square. And you have to be very careful that the value of the bending moment m can either be a constant value or it can be a function of length, that is x. So step number 3, after substituting the bending moment value in our governing differential equation, I'm going to integrate that governing differential equation one time. And we have already seen, if you integrate it once, we are going to get our slope equation. So as you can see, the equation has changed, like ei into dy by dx should be the integral of m, and while doing the integration, we will get the constant which is denoted by C1. So to find out the integration constant C1, I'm going to use a boundary condition that will be mostly the value of the slope at the relevant point. Though it depends upon each and every problem, we'll find the value of slope at a particular point on the beam. So after substituting the value of C1, again, in the step number 4, I'm going to integrate that governing differential equation once again. That means the second time to get our differential equation. So you can see here, ei into y will be equal to the double integration of bending moment plus the integral of constant C1 into x plus the second integral constant C2. So similar to C1, the integration constant C2 can also be found by using a boundary condition. The only difference here, we are going to find out the deflection value at the relevant point of the beam. So step number 5. So once you are done finding with the constants C1 and C2, you are going to substitute back into the respective slope and deflection equation, which will give the value of slope and deflection equation. So step number 6, once I am having the slope equation or the deflection equation, I am able to calculate the corresponding slope and deflection value at any point of the beam, provided you have to substitute the value of the length at the desired location. So usually we will be calculating at the free ends or at the midspan or at the maximum location. So you have to find out what is the value of the length or x at the point which you are desired to find out the slope and deflection. You will get the values. Right? With this, we conclude this video. It is only a brief introduction about how to use a double integration. Next video, we will actually see how to find the maximum slope and deflection for a cantilever beam, which is loaded with a point load at free end. So you keep subscribing and watch more videos. Thank you.